Good day to all of you. Today we shall discuss on the topic direct mapping. So it comes under cache memory and mapping functions. So what is cache? Cache is the faster memory that comes between processor and main memory. Okay. So computer is a digital device that processes what information we give. Who is the heart and brain of the computer? Processor. Where we store our programs and data? In hard disk, that is secondary storage device. It is stored there permanently. But during execution, our program and data has to be in main memory. Processor directly contacts main memory or primary memory. Main memory is also called as primary memory. So processor directly contacts main memory but not secondary storage device. Hence, during execution, our program and data, it has to be loaded from secondary memory to main memory. So every time processor will have to access it from main memory. So it may take more time. To reduce that, in between processor and main memory, one more faster memory is introduced or connected, that is called as cache. It is faster memory, faster than main memory. So because it is costly, it is implemented in smaller size. Okay. So what is the advantage of using cache? It reduces access time. Hence increases the speed of execution by the processor. So it improves the performance of a computer. Okay. How it reduces the access time? So a copy of our program under execution or data that is brought from main memory and it is copied in cache. So whenever processor needs that, it will take it from cache, not from main memory. If it is not there, then only it is brought in main memory. Instead of accessing main memory, it will access from the nearest and fastest cache. Hence the access time is reduced and performance is improved. Means speed is increased, speed of execution is increased and performance is improved. So during execution, the program is anyway loaded in main memory from secondary storage device to primary memory or main memory. Part of program or whole program. If program is small, which can accommodate in cache, that is copied into cache and be stored there. So whenever processor requests for a word, it sends its physical address, means physical address of the word in main memory. Means exactly which word it needs, physical address of that in main memory, that processor will send. Then not just that one word, but block of data containing that word is copied from main memory into a block of cache. Block means group of words. So whenever a processor asks for a word, by sending a physical address of that word in main memory, it requests. Then by memory controller unit, not just that one word, a group of words or say block of words containing that one, that block is copied into a block of cache. Okay. Hence both main memory block and cache memory block will be of same size. That is, in main memory block size if 4 words, in cache also the block size will be of 4 words, right? If 8 words, the size of both will be 8 words. Then which block of main memory is copied into which block of cache? The technique of finding this one is called as cache mapping. What is cache mapping? Where to find the main memory block in cache. The technique of finding, that is called as cache mapping. Hence, cache mapping can be defined as the correspondence between main memory and cache memory. Okay. So there are three cache mapping functions. The first one is direct mapping, second one is associative mapping, and third one is set associative mapping. So in this video we shall see to direct mapping in detail. So next we shall continue with direct mapping. For that we shall take an example. With the example we shall try to understand what is direct mapping. Here in the figure main memory is shown and this is cache memory, and this one is a block. Each are block here. Okay. This is a block in main memory and this is a block in cache. Whenever any block from main memory, it is copied into cache memory. So in which block it is copied, for that formula is used. So hence directly the block of main memory can be mapped onto cache. Means correspondence between main memory block and cache memory block can be directly calculated using a formula. So before going to actual formula, so here what is the example? So let us try to analyze that, understand it first better. So word size is 1 byte. So we shall assume that word size is 1 byte. Then main memory size taken in the example is 4 kilobytes, 4 KB. Cache size is 512 bytes and block size is 4 words. Okay. Block means group of words. In each block, be it main memory or cache, 4 words are stored. So with this data, these two diagrams are drawn. Okay. This diagram is for main memory and this diagram is for cache memory. From main memory, a block is copied into a block of cache. Where it is copied, that calculation is done using the formula. So what this figure shows here, this is block 0, block 1. So like that, block 127, 128, if we continue, 255, 56, then next we continue 1022 and last one is 1023. So from block 0 to block 1023, totally how many blocks are shown in main memory? That is 1K blocks. 1K means 2 raised to 10, 1024 blocks. Because numbering starts from 0, the last block number is 1023. That is, this is 1K blocks of main memory is shown. Why 1K blocks only are drawn here? Because the size given for main memory is 4 KB, 4 kilobytes, right? 4K bytes. But word size is telling that 1 byte. Then block size is 4 byte. Totally 4 kilobytes. In each block 4 bytes means how many blocks can be done in main memory? 4 kilo divided by 4. 1K blocks. In each block containing 4 words can be formed in main memory. Totally 1024 blocks are there. In each 4 means, so this is 1K into 4, it will be 4 KB. It is equal to main memory size 4 KB. Seeing to this data and block size 4 bytes, that this main memory diagram is drawn. Next, how cache is drawn? So cache size they have given 512 bytes. Okay. So block size in cache and block size in main memory both have to be same. So here one block, here one block, when they are same, it is accommodating 4 words here. Here also 4 words. So in each block 4 words, but totally how much it should be? 512 bytes or words. So here totally 512. In each 4 means 512 divided by 4, it will be 128. So 128 groups of 4 words in each can be made. Hence 128 blocks can be made in cache. The numbering starts from 0, then 1. The last one is 127. So 0 to 127 means totally 128 blocks will be there in the cache. To 4 is 512 bytes. So with respect to this data, this main memory and cache memory are drawn. Next, whenever a processor requests for a word, it gives the physical address of the word in main memory. Say if it is here, then instead of one word, whole block is copied into block of cache. So this block where it is copied in cache, how to find that? The technique of finding is one technique, that is direct mapping. In that a ready formula is used. According to formula, what block number comes here, in that block only that has to be copied. So what is the point here? Block in main memory is copied into which block of cache can be calculated by a ready formula. In that block only it has to be copied, though other blocks are free. Okay, so next we shall continue with that formula and doing some calculations. Understand, whenever any word is asked, the block containing that word is copied into which block of cache. Okay, so whenever processor requests for a word in main memory, it sends the physical address of the word in main memory. So that is called as main memory address of the word. So in direct mapping, it is divided into three parts. First one tag, second one block offset, third one word offset. So what is direct mapping? Whenever a word is requested by the processor, so suppose it is in this block, then instead of only one word, whole block is copied from main memory to cache memory block. So it is copied into which cache block, that is calculated by the formula. As per formula, when calculated, what cache block number comes, in that block only it is copied. So that is fixed. Though other blocks are free, they are not utilized, but as per calculation, which block number in cache we get as per formula, in that block only the block containing that word from main memory, it is copied into that cache block. Okay, so in which cache block it is copied? The formula used in direct mapping is cache block number. So in which cache block it is copied, equal to main memory block number. Means by sending physical address, when a processor has asked for a word in main memory, in which block that word is, that block number. So main memory block number containing that word mod or modulo, right? This is mod operation. Then number of blocks in cache. So this is the formula. This is what is followed in direct map. We shall see some examples in this. With reference to this figure, this is of main memory and cache. Suppose the word is in block number 127. So number of blocks in cache is 128. As per formula 127, main memory block number modulo number of blocks in the cache will give the cache block number in which it will be copied. So 127 modulo 128, that is 127. Okay, so 127 modulo 128 means 128 ones are 128, we cannot write. So 128 zeros are 0. So what is the remainder here? 127. So 127 modulo 128 is 127 only. Hence this 127 block will be copied into 127 block of cache. Hence, this block 127 of main memory will be copied into block 127 of cache. Next, if the word in main memory, if it is in block 1, where in cache it is to be copied. The block number in main memory is 1. The number of blocks in cache is 128. So, 1 modulo 28. So, 1 modulo if you do here, we cannot do here 128 zeros are 0. So, 1 minus 0 is 1. So, it is copied into block 1. So, block 1 of main memory is copied into block 1 of cache. Similarly, block 0 of main memory is copied into block 0 of cache because 0 modulo 128 is also 0. Similarly, block 127 of main memory is copied into block 127 of cache because 127 modulo 128 it is equal to 127 only. So block 0, block 1 till block 127 they are directly in the same cache blocks. Say block 0 in block 0 only, block 1 of main memory in block 1 of cache only, till block 127 of main memory in block 127 of cache. They are copied if requested word is in those blocks. Suppose if you take block 128 in main memory, where in cache it will be copied. So what is the block number in main memory? That is 128. What are the number of blocks in cache? 128. So 128 modulo 128. So here ones are, if you take the remainder is 0. So from here onwards again the blocks will be mapped to starting from 0. Now 129 if you take, it will be mapped to block 1 in the cache because block number in main memory 129 modulo 128. So 129 modulo 128, here the remainder is 1. Okay. So block 129 in the main memory is mapped onto block 1 of the cache. So this is how correspondence between main memory and cache memory is done. Means if a word is in a block of main memory, that block where it is copied in cache, like this it is calculated by the formula, that is what is direct mapping. Means for any block in main memory, the block in which it is to be copied, it is fixed. Though other blocks are free, they cannot be used, but as per calculation which block number comes, in that cache block only it is to be copied. If it is full, it has to be replaced using replacement algorithms. That means for the processor, asked word is not available. It is called as cache miss. Okay. So because block 0, then block 128, then block 256, block 512. So they are all mapped to block 0 in the cache. So when any word is asked either in block 0 or 128, okay, or 256 or 512, as per calculation all are mapped to the same cache block. So if it is full, then it is a miss. Though other cache blocks are free, it cannot be copied there. So the chances of misses are more in direct mapping. It is not flexible, and that is the drawback of direct mapping. Okay. I hope you got this point. How correspondence between a main memory block and cache block is done. That is the correspondence between main memory and cache is done. And using formula how a main memory with a block number is copied into which block number of the cache. That is what is direct mapping. The number of misses are more here and it is not flexible also, because any other blocks are free in cache other than calculated one. It cannot be copied there. Hence this is not flexible. That is the drawback of direct mapping. But the technique of finding the main memory block is found in which block of cache by using one formula. It is very simple. It is the simplest one, but it has that drawback. So some more examples if you consider in this direct mapping given example. So main memory blocks, if you take block number 0, block number 128, 256, 384, 512, 640, 768 and 896. These main memory blocks, when you do modulo operation with 128. Why 128? Number of blocks in cache are 128. So 0 modulo 128 is 0 only. 128 modulo 128 is 0 only. 256 modulo 128 is 0 only. So these main memory block numbers modulo 128 is 0 only. So whenever processor requests for a word, if it is in block 0 of main memory, then block 0 of main memory is copied onto cache block 0. Similarly, if the word is in block 128 of main memory, that is copied into cache block 0 only as per the formula. So first time when processor sends the physical address of the word in main memory, so in which block it comes, the memory controller unit assesses. Then if it is in these numbers, then as per modulo operation, then that block containing that word will be copied into cache 0 only. Okay. Suppose a word from block 128 of main memory is copied into cache block 0. Next, suppose the processor is asking for a word which is in main memory block 512. Then this block 512 of main memory has to be copied into cache block 0 only. Then the old content has to be erased. Like this, many times when words belonging to these are asked one after the other, because they are mapped onto same cache block, then they are to be overwritten. Okay, though other blocks are free, they cannot be used. So number of overwriting is more. So another example here, suppose the word is in block 1 of main memory. So 1 mod 128. So if you do, it comes 1 only. That already we have seen. Here if you see, this is 1 mod 128. So 1 is divided by 128. We cannot divide. 128 zeros are 0. 1 minus 0 is 1. So this remainder, mod operation means remainder will have to take. So in that manner, when calculated, remainder for all these numbers is 1. These are the main memory block number. So these numbers mod 128 is 1. Hence these blocks are mapped onto cache block 1 only. First, if the word requested is in block number 129 of main memory, that is copied into cache block 1. Suppose next, if the data is in main memory block of 257, that also mapped onto cache block 1 only, but old data is there. Now it is to be overwritten with the new data. So one after the other words belonging to these blocks are asked by the processor, then those blocks from main memory are copied onto same cache block number, that is 1. So many times it has to be overwritten because the asked word is not available in the cache. So number of overwriting are more, number of misses are more, and the direct mapping is not flexible, but it is the simplest one using the formula where main memory block can be found in cache, that can be easily calculated. Okay. So the last example, main memory block 1023, where it is copied in cache block number 127. How? Main memory block number 1023 modulo number of blocks in cache, that is 128. If you do here 128 and 1023, 1023 modulo this means when we divide, so 128 7s are 896, 1023 minus 896, the remainder is 127. This modulo operation means the remainder we'll have to take, hence the answer is 127. Okay, so that is direct mapping, that is how correspondence between main memory and cache memory is done. Next we shall see what this means. This is the division of physical address of the word. So whenever processor requests for a word in main memory, it sends its physical address in the main memory. So that is called as main memory address here, means it is the address of the requested word in main memory. So that whole address is divided into three parts, that is first part tag, second is block offset, and third is word offset. Okay, so what is the given data here? The main memory size is 4K bytes. Then what is the block size? 4 words. Then what is the cache size? Or 512 words. So with this data and with this kind of division of main memory address of the word, we shall find out what these bits are. In main memory, what is its physical address? Which, as already told, in direct mapping it is divided into three parts: tag, block offset, word offset. What was the given data? Main memory size 4 KB, cache size is 512 bytes, block size is 4 bytes, or main memory size is 4 kilowords, cache size 512 words, block size is 4 words, right? So 4 words means in each block 4 words are there. To identify any word in the block when 4 words are there, to address them, to identify them, 2 bits are required, because 2 raised to 2 is 4. So 2 bits are required for identifying any word in a block. Hence word offset is 2 bits. So block size is 4 words. To identify any one word, 2 raised to 2 is 4. So 00011011 will be the address or identification for each word in a block. Hence the word offset is 2 bits. Next, what is block offset? In cache 128 blocks are there. So 2 raised to 7 equal to 128. So to identify any one block in cache, 7 bits are required. That is called as block offset. Right? Then how to find tag bits? Okay. From here to here it is the physical address. The total number of bits in physical address of the word. So how many words are there in main memory? 4 kilo words are there. Right? So in main memory 4K words are there. 4K bytes means 4K words. So 4K is equal to 4 into 1024. K means 1024. 4 means, so 4K means 4 into 1024. This is 2 raised to 2. 4 is 2 raised to, so 4 here is 2 raised to 2, 1024 as it is. So 2 raised to 2, 1024 can be expressed as 2 raised to 10. So 2 raised to 2 into 2 raised to 10, that is totally 2 raised to 12. So what we have done, we have expressed 4K as 2 raised to 12. So identify any one word among 4K words in main memory. How many bits are required? 12 bits are required. Then whenever a processor requests for a word in main memory, it sends a physical address. It will be having totally 12 bits. Hence this is a physical address. Totally it will be having 12 bits. Okay. So when total is 12 bits minus 7 bits minus 2 bits, hence this will be 3 bits. Hence this will be 3 bits. That is 12 minus 7 minus 2. So 12 minus 9 is 3 bits. So what is the division of physical address here? Tag, it is 3 bits. Block offset is 7 bits. Word offset 2 bits. So what this means? So that word, which word, that is indicated by last 2 bits. In which cache block it is, that is indicated by these 7 bits in whole of the physical address. And from which memory block it is brought to cache, that is identified by tag bits. Okay. This is how the division of physical address is done in direct mapping. So that completes the discussion of direct mapping. So what was the topic? Direct mapping. That is in cache memory and mapping functions. Among the 3 mapping functions present with the cache memory, the first one is direct mapping. That was the topic discussed so far. I hope you understood. Thank you.